So I've got the table, and I think when we did quadratics, I did the same table, or close to it. Remember that if it happens inside parentheses with your x, then it's the opposite of. X is your liar, okay? So if I have x minus h, your instinct is want to say that it goes to the left. But remember that everything with x is opposite of. Think about if I had f of x plus 3, then if I set that equal to 0, that would be a negative 3. That's shifting it 3 to the left, even though there's a plus, okay? Now, if you have it outside of your parentheses, it's affecting your y, okay? The only time it affects your x is if it's inside parentheses with the x. Everything else is y, okay? So your y is as is, straightforward. If it's a plus 5, then you're going up 5. If it's a minus 20, then you're going down 20, okay? Now your reflections, those are going to be opposites as well, okay? If I have a negative f of x, remember f of x is the same as y, all right? So if I'm taking a y value and I'm negating it, what axis is that flipping over? If I have a positive y value, say positive 5, and I now make it a negative 5, I'm flipping it down so it flips over the x-axis. So it affects my y, but I'm flipping it over the other axis. Does that make sense? So if I have f of negative x, say I have a positive 3x, and then I'm going to make that negative. So I flip that horizontally, which is over the y-axis. Okay? All right, and then your stretches, remember that if it's inside, it's the opposite. So if I have 1/2 x inside my parentheses, it's really a 2. It's a stretch. Everything inside is the opposite of what you would think, okay? So if I had a 2, that's really a shrink by 1/2. If I had a 1/3, then that's a stretch by 3. If I had a 7, that's a shrink by 1/7, okay? But whenever it's out front, that's as is. If it's 8, then it's a stretch. If it's 1/4 or 1/8, it's a fraction between 0 and 1, then that's still going to be a shrink. So the only thing you have to think about is when it's inside parentheses, okay? Alright, so I basically summed this up. I don't need to read that again. You can go back if you want to, but I already said that. If it's in parentheses, it's your x, opposite of. Okay. So we're going to look at our parent cubic function. You should know your parent quadratic function, y equals x squared, and you should know that parent function table. We would do -2, -1, 0, 1, 2, right? And it would be 4, 2, 0, 2, 4. Or 1, 4, 1, 0, 1, 4. Okay, so that was when you would do y equals x squared. Now we're doing y equals x cubed, and we're going to use those same x values, so -2, -1, 0, 1, and 2. And we're going to take that and we're going to cube it. So if I take -2 and cube that, that gives me -8. -1 cubed, 0 is 0. 1 cubed is 1, and 2 cubed is 8. So with quadratics, remember that it was a symmetric graph. It was a parabola, so everything repeated around a vertex. We had a vertex, which was your highest or lowest point. Okay? With a cubic function or any odd degree function, you have an inflection point. Okay, so it's no longer a vertex because you're not perfectly symmetric. It's not going to be a high or low. An inflection point is the point where your direction changes. Okay, so you have a change in direction, and it's typically the middle of the graph. Okay, so where we would think it's a vertex, it's now an inflection point. So 0, 0 is our inflection point. Okay, so remember that even functions, they end the same direction, right? But your odd functions are always opposite directions. Okay, so that's why we need that inflection point. So every time we have an example, we're going to do our parent function, and then we're going to do the transformation. Now, they're not always going to be x cubed, okay, but we're going to use those same x values, -2 to +2, and we're going to plug that into whatever our parent function is, okay? So if I have x cubed minus 4, my parent function is just going to be my x cubed. So I'm going to have my -2, -8, -1, -1, 0, 0, 1, 1, +2, +8. Okay? Now we're going to build our table looking at this function. My function is x cubed minus 4. So is anything happening to my x? No. So my x's stay the same. But what's happening to my y? I'm doing y minus 4. So I'm going to take the y values from my parent function and subtract 4. So -8 minus 4, -1 minus 4, 0 minus 4, 1 minus 4, 8 minus 4. Alright? So we're going to graph both functions. If you want to do a colored pen, if you want to get that out, you can do a colored pen now. Now my -2, -12, I know is going to be somewhere below. I probably did that too low because it goes to -11. Draw your graph as accurate as possible, but it's okay if it's not perfect. So once you graph it, we have to state the inflection point if there is one. So for an odd degree function, you're going to have an inflection point. And then we're going to talk about the transformations. Okay, so my new inflection point is where? 0, -4. That center of the graph. And then the only transformation I had was what? It translates down 4. Okay, y'all good with that? Very simple. Alright, now I have g of x is equal to x plus 5 cubed plus 2. So I still have a cubed. My parent function is still x cubed. So -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. If you want to go ahead and graph that, you can before you do your transformation. Then for your transformation, what's happening to my x? In my table, I'm going to do the opposite. It's going to subtract 5. So everything is opposite in parentheses. And then what's happening to my y? So negative 2 minus 5, negative 1 minus 5, and then, all right, and then negative 8 plus 2, negative 1 plus 2, then 2, then 3, and 10. What's your inflection point? Okay, I had two transformations. What were they? Translates left 5 units and up 2 units. All right, now, example 3, I have negative 1/4 x to the 4th. So what's my parent function going to be? X to the 4th. I'm still going to use negative 2, negative 1, 0, 1, 2. But now negative 2 to the 4th is going to be 16. Negative 1 to the 4th, 0, 1, and then 2 to the 4th, 16. So this graph is going to resemble like a quadratic, okay? It gets a little bit flatter. Instead of right around the vertex, it gets a little bit flatter, but it's going to look pretty much the same. Now, negative 216 is going to be way up at the top, so just estimate wherever you want to put it. So then for your transformation, is anything happening to my x? No. For my y, I'm multiplying y by negative 1/4. Okay. So when you do this, 16 times the negative 1/4 is negative. Now 1 times negative 1/4 is a negative 1/4, which you can put a decimal. I'm okay with this. 0.25. 0 stays 0. 1 is, no, this should be positive. No. Okay. Alright, this is going to give me negative 0.25. And then I've got negative 4 again. Do I have an inflection point? No, your inflection point is only whenever you have odd degrees, okay? So you can tell me none, but you're just going to tell me your transformation. So I know it reflected, but where did it reflect? Okay. And then was it a stretch or a shrink? It's a vertical shrink. Make sure you put vertical by a factor of 1/4. Okay, now I have 2x raised to the 5th minus 3. So my parent function would be x to the 5th. So negative 2 raised to the 5th. Negative 1 raised to the 5th. It's negative 1. 0, 1, and then now positive 32. Clearly, that's not going to go on your graph, okay? So all you have to plot is what will go on your graph, but just know when it's at 2, it should be way up here. So you should not, when you're graphing this, you should make it as straight as possible going upward and not crossing past that 2 yet. Now, I have a 2x in parentheses. It's always opposite of. So really, I'm not multiplying by 2. I'm multiplying by 1/2. But my y, I'm subtracting 3. So negative 2 times 1/2, negative 1. Negative 1 times 1/2, you can put the decimal. 0 times 1/2, 0. 1 times 1/2, and then 2 times 1/2. Then y minus 3, negative 32 minus 3. Negative 1 minus 3. Then negative 3, negative 2, and 29. So all I can really plot is that negative half down to negative 4. 0, negative 3, and 1/2, negative 2. It's going to be very narrow. Do I have an inflection point? 0, negative 3. Now, with your transformations, it happened to my x. So that is a horizontal. I did a 1/2, so that's a shrink. By a factor of 1/2. So make sure if it happens to x, you say horizontal. If it happens to y, it's vertical. Okay? And then what else happened? Translates or shifts down 3 units. Okay, example 5. I think we can just describe what happens. I think y'all don't need to graph that, right? I think y'all are good. So, what does this negative tell me? It's going to reflect where? Over the x-axis. Now this 0.5x, it's inside parentheses, so what is that going to make it? You're going to multiply it by 2. It would be 2x here, so it would be what for my transformation? Horizontal stretch. Okay? It would make it a horizontal stretch because you're multiplying it by 2. You're multiplying it by a number greater than 1. Okay? And then this plus 2 tells me, so y plus 2, you would really have a negative y plus 2. So when you do that, you would negate the y, then add the 2. Make sure you do order of operations. Okay? And that would just make it go up 2. Okay? I think y'all would be fine not graphing that. Okay. All right, so now moving on, writing transformations of polynomial functions. We're going to write the equation. So if your instructions say write a rule, it's talking about an equation for g of x, and you're going to describe the transformations. So if my original function is x cubed plus x squared plus 1, and I need to make it f of negative x. That means anywhere there is an x, I'm replacing it with a negative x. So here, g of x, I have a negative x in parentheses raised to the third power, plus negative x raised to the second power plus 1. Well, negative x to the third power is just negative x cubed. Negative x to the second power plus 1. So what would my transformation be? Reflection over. It's happening where? Inside parentheses. It's happening to my x, so I would be reflecting over the y-axis. Okay. Part B says we're doing 3 f of x. So you take that 3 and you're going to distribute it to everything for my function. So g of x will now equal 3x cubed plus 3x squared plus 3. And what is that transformation? It would be a vertical stretch by a factor of 3. Y'all good with that? Do we have questions? Okay. So now I have a new function and I'm doing negative f of x. So I take a negative on the outside and distribute it. So essentially all my signs are changing. Negative x to the 4th plus x cubed plus 1. What was that transformation? It reflects over the x-axis this time. So would y'all know what to do with 1/3 f of x? Yes, we can skip that too. All right, now we're going to write a rule or an equation for g of x that represents the indicated transformations of the graph. So now I'm giving it to you in words. I'm giving you the transformation, and we're going to have to figure out how to manipulate this equation, this function. And this should have an f here. F of x is equal to x to the fourth minus 2x squared. So we are going to stretch it vertically by a factor of 2. So that is 2f of x. And then once you do that, you're going to do 3 units up. So that's your plus 3. Alright? So we're going to have 2 different transformations. So first we're going to say, let's do, you want to end with g of x. So let's say we have h of x. So I'm doing 2 times f of x. So 2 times x to the fourth minus 2x squared, which is 2x to the fourth minus 4x squared. Then my g of x takes that h of x that we just built, and we're going to add 3. So g of x is equal to 2x to the fourth minus 4x squared plus 3. So I do want to see you tell me this. I want to see what that rule is before you do that equation. Okay? So my next example, I have f of x equals x squared plus 4x minus 3, and we're going to do a horizontal stretch by a factor of 2, followed by a reflection over the y-axis. Alright, so if I'm doing a horizontal stretch that happens inside parentheses, it says by a factor of 2, so what should I have inside parentheses? 1/2 x, right? Because it's the opposite. I'm not going to multiply by 2, I'm going to multiply by 1/2. So everywhere there's an x, I'm now going to replace it with 1/2 x. So 1/2 x raised to the second power, I'm going to square 1/2, and that becomes 1/4 x squared. Plus 4 times 1/2 is 2x minus 3. Then my g of x, followed by a reflection over the y-axis. So if it's going to happen over the y-axis, what am I really putting the negative on? In the parentheses on my x, right? It's going to flip over the y. My y is here, so I'm flipping over that. So is that up and down or horizontal? Horizontal, so it has to happen to my x. So it's h of negative x. Okay? So I'm going to have 1/4 times negative x squared plus 2 times negative x minus 3. So that's going to be 1/4 x squared minus 2x minus 3. Are y'all good with that? Do you have questions? Okay, you will have a quiz over this.